All right, let's talk about something that hits close to home for a lot of us in the tech world. Have you ever opened up your Google Cloud bill and just felt your stomach drop a little? Well, you are definitely in the right place. Today, we're going to turn that confusion and dread into some real actionable wisdom. Let's get into it. So let's just start with the million-dollar question, right? The one that keeps engineering leads and finance teams staring at the ceiling at night. Are you overpaying for the cloud? Chances are, if you haven't been super intentional about optimizing, the answer is probably a big fat yes. And honestly, this is the best way to think about it. The biggest source of cloud waste isn't some super complex hidden fee buried in the terms of service. Nope, it's way simpler. You're paying for stuff you provisioned but aren't actually using. It's like you've got this huge 10-bedroom mansion, but your whole team is just hanging out in the kitchen and the living room. You're still paying the mortgage on all those other empty rooms, though. And that brings us to what I like to call the hidden cloud cost. It's kind of the silent killer of tech budgets, right? It's all that idle capacity. It's not going to show up on your bill as a line item called waste, but believe me, it is there, quietly pumping up your costs month after month. So where do you even start looking? Well, here are the usual suspects. You've got your Google Compute Engine instances just chugging along at like 10% CPU. You have Google Kubernetes engine nodes that are basically sitting around waiting for something to do. And of course, those giant oversized cloud SQL instances for a database that just doesn't need that much muscle. These are your empty rooms. Okay, so how do we find these empty rooms? It's time to put on your cost detective hat. And don't worry, you don't need a magnifying glass for this, just the right tools that are already sitting there inside your GCP console. And here it is, your simple 3-step action plan. First, you're going to jump into cloud monitoring to get the real data. What's your CPU and memory usage actually look like? Second, you use that data to pinpoint the exact instances that are always underused. And third, and this is my favorite part, you just review the recommendations that GCP automatically gives you. Google's tools will literally tell you, hey, you could save a bunch of money just by resizing this machine. They do the work for you. So once you've right-sized everything and cleaned house, we get to the next level of savings. And this is all about discounts. GCP has two really powerful but really different ways you can save money. An automatic discount applied to GCE and GKE resources that run for a significant portion of a billing month. No commitment required. First up, you've got sustained use discounts, or SUDs. Just think of these as the easy button for savings. You literally don't have to do anything. If you run a VM for more than a quarter of the month, Google just automatically starts giving you a discount. The longer it runs, the deeper the discount. It's a total no-brainer. But if you want to go for maximum savings, that's where committed use discounts, or CUDs, come in. Now, this is a strategic move. This is you going to Google and saying, look, I promise I'm going to use this much CPU and memory for the next 1 or 3 years. And in return, they give you a massive discount. We're talking up to 70% off. It's huge. So let's just break that down real quick. SUDs, they're automatic, they're flexible, no commitment, and you get up to 30% off. Pretty great. CUDs, on the other hand, you have to manually commit for 1 or 3 years, but that unlocks savings of up to 70%. So the choice really just boils down to one thing. How predictable is your workload? Now, all this theory is great, but what does it actually look like in the real world? Let's take a look at a quick story from a team that actually put all this stuff into practice. This is a quote from a real team lead, and man, does this sound familiar, right? They had that classic problem. The bill just kept going up and up every single month, but where the money was actually going felt like a complete black box. They knew they were wasting money, they just couldn't see where. So what they do? They followed that 3-step plan we just talked about. They dove into cloud monitoring, they found all their oversized instances, and they right-sized them. Then they looked at their baseline, the servers that are on 24/7 no matter what, and they made a pretty modest commitment. And the result? Just look at this chart. The before bar is where they were. The after bar is their new reality. The difference is it's dramatic. How dramatic? They slashed their compute costs by 40%. 40! That is not a small chunk of change. That's real money that can go back into hiring another engineer, building new features, actually innovating. That's a total game changer. And all of this brings us to the final, really practical question that you have to ask yourself. How do you decide? When do you commit? And when do you stay flexible?
Well, here's your decision-making framework, and it's actually pretty simple. For all of your stable, predictable workloads, I'm talking about your core app servers, the databases that run 24/7, you commit. Lock in those CUDs and maximize your savings. But for everything else, the new experimental projects or workloads that have really spiky, unpredictable traffic, you stay on demand. That gives you the flexibility to scale up, down, or even turn them off completely without any penalty, and you'll still get those nice automatic sustained use discounts.
So there you have it. That's the blueprint to go from cloud waste to cloud wisdom. The tools are right there waiting for you. The strategies are clear. So really, the only question left is, what savings are hidden inside your cloud, just waiting to be found?